Okay. So what I was saying was, today we are going to start Unit 3 of Pre-Calculus as per the Khan Academy. And why I'm calling out the unit name because so that after the class you can probably go back to the unit and do the unit test and see whether whatever we are learning in the class is that enough or not. Okay? Or at least is that helping you or enabling you to solve the problems conceptually or not. Okay? So we are going to start unit 3, which is complex numbers. So we have talked about complex numbers in the past, right? In the previous class only we were talking about it in the SAT, this thing, right? Whenever you have a number, something, let's say z as a plus bi, meaning there is a real component to it and there is an imaginary component to it. So a complex number, as we know, it's a combination of real plus imaginary components together. That's why it is called complex number. This part you would remember, right?
Yes, sir.
Now, in today's class, again, it's not going to be much of a learning. It's going to be more of fun with complex numbers, if I can put it that way. So, first thing is, I'm not sure if we talked about how do we plot a complex number on a complex plane. So when you say complex plane, it is nothing but the coordinate plane, where in the coordinate plane you have x and y axis. In the case of a complex plane, you have x axis as is called real axis and this is called imaginary axis. So this is your x axis and this is your y axis. In complex plane, this is called real axis and this is the imaginary axis. So that is how when you plot a complex number on a coordinate plane, this is called a complex plane. Yeah. So let's say I have a complex number as 2 plus 3i. I will treat this as x and I will treat this as a y. So whatever is my real component of the complex number, that will be on this in this direction, and whatever is my imaginary component of the complex number, that will be along this axis. Are you with me so far, Dave?
Yes, sir.
Okay. So now if I have to plot this complex number 2 plus 3i, let's say this is 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Let's say this is 1. Okay. So if I have to plot 2 plus 3i, I'm looking at the real component, which is 2 along this axis. So this is 2 plus 3i. So 3i meaning 3i on the imaginary coordinate. So 3 and 2. This becomes this is how we plot a complex number. So tomorrow if I have to, let's say, plot z1 equals 1 minus 2i. It will be 1 on the real axis. So here minus 2i. So this is plus and this is negative. Minus 2i. So 1 and 2i. This will be my second point. So this is how you plot a complex number on a complex plane. I mean, we don't call it coordinate plane, we call it complex plane. This part is fine, right, Dev?
Yes, sir.
Now, let's say we are dealing with, let's say two numbers, two complex numbers, z1 as 3 plus 6i, or let's say 3 plus 3 minus 2i, and z2, second complex number, which is, let's say, 5 plus 3i. Now if I have two complex numbers, we might be asked to find out what is the midpoint and the coordinates of the midpoint. Any guesses that you can make? If somebody says what will be the midpoint of the two complex numbers and what will be the, and what is the value of the midpoint as a complex number? How would you find that out? Any guesses?
For the midpoint, I think we can just we have to look at the x value, so we could just do 3 plus 5 divided by 2 for the midpoint.
Okay.
And then for wait, what was the other part to that?
Minus 2i and here is plus 3i. So there are 2 points. One is the midpoint of the two complex numbers and the distance between the two complex numbers and the coordinate basically. So let me put it this way. How do you find out the midpoint of a pair of complex numbers? That is the first thing. Second is, what is the distance between the two complex numbers? That is the second thing. And third is, no third actually, first one. How do you find the midpoint? If you find the midpoint, meaning there will be a midpoint. I mean, if I am talking about a midpoint, let's say I have two points. Midpoint will be somewhere here. So how do I identify the midpoint? By finding out the x and y coordinate, right? Since we are talking about complex numbers, so I have to find out the value of the complex numbers will be the midpoint of these 2 points. So I have to find out the midpoint and find out the distance between the two complex numbers. So how do we find it out? Yeah.
So we can tell this is a linear graph. So we could just use a midpoint formula for both the x and y values. So for the x, it's 3 plus 5 divided by 2, and then for the y, it's negative 2 plus 3 divided by 2. And then we should point in between them.
Okay. And how do you find the distance between the two complex numbers?
For the distance, after we find the midpoint, we could just after we find the midpoint, we could do the distance between one of the points to the midpoint and then just multiply that by 2.
Yeah, that could be. So I think you already know it, but I'll just do it just one time for the sake of completing the whole circle. Okay, so I have 2 points, z1 as 3 minus 2i, and second complex number is z2 as 5 plus 3i. So when I plot this on a complex plane, 3 minus 2i, 3 minus 2i. So it will be somewhere here. This is my one. This is the first complex number, and when I plot the second complex number is 5 plus 3i. So 5 plus 3i. So it will be somewhere here. 5 here, 3 here. So this is my second point. So what we have to find out is the midpoint, meaning join these two. Okay. So connect these two. So basically connect these 2 points and the midpoint will be somewhere halfway through. So as you said, I mean, if you have to find out the midpoint, it's very simple, right? If you visualize this, just draw a perpendicular here. See, if this is my midpoint, you can also draw a perpendicular here. So or don't do all that. It's very simple. The midpoint will be, so the real value of this point and real value of this point divided by 2. This will be my midpoint. Likewise, as you said, the midpoint, the imaginary part will be this plus this divided by 2. So you simply add them and you'll find out that that's not a big deal. So that, let me not waste your time doing it. So my midpoint will be 3 plus 5 divided by 2 plus minus 2 plus 3 divided by 2i. And that will be my midpoint. But when it comes to distance, this one, you said that you will find out the midpoint and then again the distance between these two and multiply that by 2, or you can look at this as a Pythagorean theorem. you'll find from here to here what is the distance. Basically, the real component of the second point minus the real component of the first point, that gives you this distance, which will be 5 minus 3. So this is this is a right angle triangle. You can look at it this way. I've just drawn a perpendicular. So this gives you this length, and then you find out this length, and then use the Pythagorean theorem to find out this length. So that is another option that you can do. So whichever way it works for you, right? So what I was saying was, you have to find out this distance. So you can certainly find out what is the value of this length and the value of this length. So this length, you can see that this is the difference between this and this. So you get this length. Likewise, this one is nothing but the -2, which is here, and 3 here. So total length is 3 plus 2, 5. So basically, square of this and square of this will give you square of this. So your distance would be what? 5 minus 3 square. So your distance square will be 5 minus 3 square, and this one. So this is total 5i. So it will be like 3 plus 2i square. So this becomes d square equals 5 minus 3 square is 2 square is 4 plus 3 plus 2, 5i square. So 5 square and I square. So that gives you this length. Yeah. So 5 square 25, and then this is I square is -1. I mean, from this you can find out this total value. Yeah. So it's up to us how we want to find this out. Ultimately, there are two parts to it. One is how do we visualize this when you plot this on the coordinate plane or the complex plane, and then use the Pythagorean theorem to find out this distance also. Any ways that you can apply should be fine. Up to this much, okay, or something is still bothering you?
No, sir.
Okay. Okay. Now there is another concept that we need to know about, is called conjugate. Are you aware of a conjugate of a complex number?
No, sir.
Okay. So let's say if I have a complex number z as 3 plus 2i. My conjugate just reverses the sign of the imaginary part. So if I say conjugate, let's say as j of g, it will be 3 minus 2i. If I have complex number c as 5 minus 2i, the conjugate of this complex number would be 5. The real part doesn't change, only the sign of the imaginary part changes. It reverses from plus to minus, minus to plus. So it will become 5 plus 2i. Yeah? So that's what is conjugate. Now you tell me, why do we need this? Because this actually helps us with a lot of calculation. So let's look at it this way. If I have a complex number as 3 plus 6i, what will be my conjugate of this number?
3 minus 6i.
3 minus 6i. And if I multiply the complex number with its conjugate, can you tell me what will happen? I'm talking about essentially multiplying 3 plus 6i with 3 minus 6i. And if you look at it carefully, it's a plus b into a minus b. Yeah?
Yeah.
So this becomes a square, which is 3 square, minus 6i square. Sorry, this way. Yeah? So what will happen is it becomes 9 plus 36, 9 minus 36 I square, and I square we all know is minus 1, so 9 plus 36. Yeah. So essentially what is happening is when you multiply a complex number with its conjugate, it becomes a real number. Okay. So that's the takeaway here. So it just helps you, if you have any complex number, if you multiply that with its conjugate, it just converts the whole, the outcome is a real number. Yeah?
That makes sense, sir.
Yeah. Now you will say that is understood. A conjugate, when you multiply a complex number with its conjugate, it gives you a real number. What is the big deal? Why do we even need that concept? We can literally just do away with this. So there is one more dimension to it. Now the actual fun starts. If I say 6 plus 3i, divide that by another complex number, 2 minus 2i, or 2 minus 7i. Do you know how to do the revision? And what is the objective here is, when I divide a complex number with another complex number, I'm essentially looking at getting a simplified version of a complex number. Something like this, not exciting enough. So if you are given to divide a complex number by another complex number, how would you approach?
Was this one like the reciprocal, or
Say that again?
would we like do like a reciprocal value? Or like, or can we just like do 6 divided by 2 for this? And like,
So if you do 6 divided by 2, meaning you're dividing everything here by 2. By 2. Is that what you're saying?
yeah.
That might not give you a clue. I'm still thinking about your recommendation to see if that works, right? If I divide everything by 2, this one becomes 1, this becomes 7 by 2. This becomes 3, this becomes 3 by 2. So instead of things becoming simplified, it's kind of getting a little complicated here. Yeah?
Yeah.
So now, this is where a conjugate thing comes into picture. And the way we can solve it is, always look at the denominator and multiply it with the conjugate of the denominator. Okay? Since you multiplied here, you have to multiply here also. Yeah? So now two concepts are coming together. We discussed about any complex number being multiplied with its conjugate gives you a real number. That means a countable number, usable number. That is how now you look at it. 6 plus 3i multiplied by 2 plus 7i. We will deal with this a little later. But look at the denominator. It became this into this, a minus b into a plus b, which is a square minus b square. Yeah? So this became 6 plus 3i multiplied by 2 plus 7i divided by this square is 4 minus 7 square is 49 into I square, which is minus 1. So this becomes plus. So this became 6 plus 3i multiplied by 2 plus 7i divided by 53. Now this is a much more simplified version of a complex number. And we are not done yet. I'm just showing you that our problem was primarily with the fact that we had a denominator with a complex number that was not giving us that comfort. Now I have a number in the denominator. Yeah? Let's see what happens to the numerator. 6 plus 3i into 2 plus 7i. So 6 into 2 is 12. 6 into 7i is 42i. Then 3i into 2 is 6i. plus 3 into 7, 21, 21 into I square by 53. That becomes 12 plus 42 plus 6i. 42 plus 6i is 48i. So 12 plus 48i plus 21i square. So plus 21 into minus 1 divided by 53. It became 12 minus 21 plus 48i divided by 53, which is 12 minus 21 is minus 9 plus 48i by 53 or 48i. So you can say minus 9 by 53 is my real component plus 48 by 53 I is my imaginary component. It became like a true simplified version of a complex number. Yeah?
That makes sense.
Yeah. So basically net, if you look at it, when you have to divide a complex number by another complex number, you will use two things. One is your conjugate always helps you. Conjugate of any complex number helps you simplify that to a real number. So the problem is always with the denominator. If your denominator is complicated, your whole calculation goes for toss. So you would certainly want to knock off the denominator in a way that becomes much more convenient to deal with. So to knock off the denominator, you multiply that with the conjugate, which helps you convert this to a real number, and whatever you are multiplying here is what you will multiply this with the numerator also, and then you go here. Yeah. So now conjugate becomes a weapon for us to solve not a weapon, actually a medium for us to solve or divide a complex number by another complex number. Yeah. Does that make sense?
That makes sense, sir.
Okay. All right, sir. Fine. So let's look at what else we had kept in the topic for today. Let me. Okay. So we talked about plotting complex numbers, finding midpoint and distance, conjugate of complex numbers, dividing complex number by complex number. Now factor sum of its squares. Since you are the only child in the class, I'm sorry for calling you a child, but that is how I treat you guys. So this is an interesting concept, factor sum of squares. So here again you will see the concept of conjugates working for us. Now, if you look at x squared minus y squared, if you have to factorize this, you are very comfortable doing it, right? It's like a squared minus b squared. And you'll say, yeah, I know this is x plus y times x minus y. No problem so far, correct? Yeah?
Yes, sir.
Now, on the contrary, if I say factorize this, we don't have a formula for this, or we did not have a formula for this till we have not ventured into the space of complex numbers. Yeah? Now, if I have to factorize the sum of squares, I can do it because we have learned we can do it because we have familiarized ourselves with the concept of can we say like this? X squared plus y squared is x squared minus y squared times minus 1. We can do that?
Yeah, I think that makes sense, sir.
So that will become x squared minus y squared into minus 1 is nothing but I squared. So now I have x squared minus iy or yi, whatever you call it. So earlier when we had something square minus something, subtraction of squares, we were able to factorize it. Now, with the comfort with the complex numbers, we are able to factorize even a sum of squares. So when you have something square plus something square, we are able to factorize this, because now this becomes x plus iy times x minus iy. This would not have been possible if you would have not come across this concept of complex numbers. Yeah?
I see, sir.
Yeah. So, since you are alone, I was able to move pretty fast. So let's solve two sums quickly. I would want you to give it a shot, and then probably we'll disperse. Okay. Now there are two problems. Okay. One is 4 minus 3i divided by 2 plus I. I want you to divide this complex number with this complex number, and then I want you to convert x square plus 36y square. Factorize this one. Yeah?
Wait, sir, should I just talk to you about it since I'm the only one here, or?
Yeah.
Okay. So for the first one, then we would first find the reciprocal. So it'd be times the top and bottom by 2 minus I. And then we could we know that it'll be equal to x minus y, x squared minus y squared for the bottom. So we can get that number. And on the top, we have to go do it manually. Let's get and then we can simplify it, and that should be about it. Right?
So how about you just try solving it, okay? Because I strongly believe in the fact that when it comes to maths, right, it's better to get our hands dirty, okay? That's how your fingers will move fast. Just try solving it. And I will also solve, okay, don't worry. I mean, I'm not trying to be lazy. I'll certainly solve it. Okay? And then let's try solving this one also. And then once you are done, then I will solve it and you'll just match that whether my approach and your approach was same or different. Okay? Yeah?
Yes, sir.
Okay. Let's do it, okay? So I'm giving you 5 minutes because I know that you are pretty clear with the concepts. Let's see if you are able to solve this in 5 to 6 minutes. In a way, we are doing some time management also. We are practicing time management. Let me know once you're ready, Dave.
Oh, sir, I just finished.
Okay, both of them?
Yeah, both of them.
Wonderful. So, I will not ask you what was your answer. Let me do it also at the same time. So, I mean, just step by step, and then you will verify your answer with this one. So, when I have to divide a complex number by another complex number, what we have learned is we have to divide the multiply the denominator with its conjugate. And same thing goes here. So this becomes 4 plus 3i divided by 2 plus I multiplied by 2 minus I. And then I have to multiply the same thing in the numerator also. So this becomes 4 plus 3i and 4 plus 3i. Let me do it also. 4 into 2 is 8. 4 into minus I is minus 4i. 3i into 2 is plus 6i. 3i into I is minus 3i squared divided by 2i to a plus b to a minus b, a squared minus b squared, so 2 squared minus I squared. So this became 8 and this became 3. 3 minus 3 into I squared is minus 3 into minus 1 became 3, so 8 plus 3, 11. This is my real component plus minus 4i plus 6i, so that gives me 2i divided by 2 minus I squared, so 2 minus minus 1, that is 2 plus 1. So it became 11 plus 2i divided by 3. Is that what you got, Dev?
Yes sir, that's what I got.
Okay, wonderful. Then none of us made any mistake here. So this part is fine. Now, when you go to this one, again, this is simple. So far, before we got exposed to complex numbers, we didn't know how to factorize a square. But since we have complex number concepts with us, that's what we can use. So we can certainly write this as, our main objective is to convert to this formula. And so to achieve that, we have to get a negative here. So if I want to get a negative here, I can do that by putting a negative here. And then we know that this is x square minus 36y square, and minus 1 is nothing but I square. So this is x square minus 36 is nothing but 6 square into y square into I square, or you can say x square minus 6yi square. So now we got a square minus b square, so it will be a plus b, which will be 6y times I into a minus b, that is x minus 6y times I. Is that what is matching with the answer as well?
That's what I got too, sir.
Okay.
Yeah.
Then that kind of brings us to the end of the class. This is all we wanted to cover today, and we are able to finish it in 36 minutes because you're the only one. When we have more students, then there are more questions, there's more wait time for everyone to finish the things. So I will let you go. Make sure that you stay warm. It's pretty cold tomorrow. I mean, Chicago is no big deal. You get enough snow every day. But yeah, it's going to be much cooler than other days. So stay warm, and we'll meet again on Saturday.
Okay, sounds good, sir.
All right. Bye-bye. Take care.
Alright, bye, sir.
Good night.